Correlation tests whether the relationship between two variables is linear or not. It quantifies the extent to which two quantitative variables move together. When high values of one variable are associated with high values of another variable, a positive correlation exists. When high values of one variable associated with low values of another variable, a negative correlation exists. The correlation value ranges between -1 and +1. Open the file leadership.sav. This file contains data from a survey conducted in a large information technology company. Questionnaire was used to source this data. It has two independent variables, that is intellectual stimulation and inspirational motivation, and two dependent variables, employee empowerment and job satisfaction. Team members in software development teams rated their team leaders' leadership attributes on independent variables and their personal feelings of agreement on dependent variables. You are asked to find out whether intellectual stimulation was related to employee empowerment. The first step is to plot the data on scatter diagram with independent variable on x-axis and dependent variable on y-axis. Click on the Graphs tab appearing on menu bar. From drop-down list, move cursor pointer onto Legacy Dialogs. Another pop-up window opens. Click on the scatter or dot. A dialog box appears on the screen. From options, select Simple Scatter and click on the Define button. Simple Scatter dialog box is displayed. Select Intellectual Stimulation from left pane and click on the right arrow appearing before x-axis. Next, select Employee Perceived Feeling of Empowerment and click on the right arrow appearing beside y-axis. Click on the OK button. Scatter diagram is displayed in a new output window viewer. Double-click on the graph. Chart editor window appears. Here, click on the Elements tab on menu bar and click Fit Line at Total. Close the Properties window and close Chart editor. A trend line is fitted to data and R-square value, that is coefficient of determination, is displayed on top right corner. Here, even though the data is linear, the strength of association is weak, that is R-square is just 0.272. As you found linear relationship, move on to perform correlation test. Click on the Analyze tab on menu bar. From the drop-down list, move cursor on Correlation. A pop-up window opens. From the options, select Bivariate. Bivariate Correlations dialog box is displayed. From left pane, select Intellectual Stimulation and Employee Perceived Feeling of Empowerment and click on the right arrow appearing between two panes. Observe that both the variables appear on Variables pane. In Correlation Coefficients, select Pearson and in Test of Significance, select Two-Tailed. Click on the flag Significant Correlations and click on the OK button. Correlation test results are presented in Output Viewer. Click the mouse right-click button. From list, highlight Edit Content. Pop-up options box is displayed. Select Edit in separate window. Select the cell values and click on the Format tab. From drop-down list, select Cell Properties, then click on Format Value. In Category, select Number and in decimals enter 2. Then click OK. Close the Pivot Table Correlations window. Your correlations matrix now displays numbers with 2 decimal points. Observe the correlation results. The correlation between intellectual stimulation and employee engagement is positive. That is 0.52, and this value is statistically significant at 0.01 level of significance. There are no hard rules to interpret the correlation value. The generally accepted convention is that if correlation is less than 0.3 is considered as weak correlation, and correlation between 0.3 and 0.7 is considered as moderate correlation, and any value above 0.7 is considered as strong correlation. Consider these for both positive and negative correlations.